So in this video we're going to talk about friction. Now when an object is moving along a surface, friction is a force which acts in the opposite direction of its movement. So let's start out with this simple example. Now imagine this guy is trying to push this box along the surface. Now the heavier the box is, the harder it will be to push the box along. And this is because of friction. So friction equals a friction constant, which is this symbol right here. This is a Greek symbol called mu, multiplied by the normal force. Now, if you want to learn more about the normal force, then watch this other video. So let's say the box has a mass of 15 kilograms, and the friction coefficient between the box and the surface is 0.4. So what if we wanted to know the amount of force that the guy has to apply to move it along the surface? Now, since this is a statics problem, the first thing that we do is draw a free body diagram. So if we draw a free body diagram, in this direction we'll have the applied force. In the opposite direction, we'll have the force of friction, since friction always acts in the opposite direction of movement. Then going down, we'll have the force of gravity. And coming up, we will have the normal force. So now if we create some equilibrium equations, we should be able to solve for the applied force that is needed to move the object along the surface. So for the equilibrium equation in the x direction, in the positive x, we have the applied force. And then in the negative direction, we have the friction force. So if we solve for the applied force, which is what we're trying to find, we'll find that the applied force just equals the friction force. And this is because in order to move the box, the friction force needs to be overcome by the applied force. So now we know that the applied force equals the friction coefficient, which is 0.4, multiplied by the normal force. But how do we find the normal force? We need to create equilibrium equations in the y direction. So doing this, we get the forces in the y direction equal to 0, and in the positive y direction we have n, and in the negative y direction we have the force of gravity. So we find that the force of gravity is equal to the normal force in this question. And if you remember, the force of gravity is simply equal to the mass times 9.81, or the gravity acceleration coefficient. So if we put this in on our calculator, we find that the normal force is equal to 147.15 newtons. Don't forget your units. So now we have the normal force, and we know what the friction coefficient is, so now we can just simply find the force that we need to push the box forward. So if we do 0.4, which is unitless by the way, times 147.15 newtons, then the applied force that we need is equal to 58.86 newtons, and that is the right answer. So again, what this means is that the guy, in order to move the box along the flat surface, must push it with a force of 58.86 newtons. So these kinds of problems are a little bit more complicated because we're dealing with an inclined plane, and the normal force and the force of gravity are not parallel with each other. Now if you saw my video about normal force, you'll know this is because the normal force always acts perpendicular to the surface. So in this question, the normal force will be pointing in this direction. Now if you look at this box, it wants to slide down the ramp, but the only thing stopping it from doing that is called static friction. So static friction acts on objects which aren't moving. So if the force of friction is greater than the coefficient of friction times the normal force, that means that the box will not move because the force of friction is greater than the forces trying to pull it down the ramp, which is related to the normal force and the coefficient of friction. So in this question, we're going to try and find out what the force of friction is with respect to the inclined plane angle. And that's because if we raise the angle of the ramp, that means that the box will slide down. So basically we're just trying to find the maximum angle where the box will stay still and the force of friction will be great enough to stop the box from sliding down the ramp. So since this is a statics problem, we start out with drawing a free body diagram. In the opposite direction of movement, we have the friction force. Now, pointing straight downwards, as always, we have the force of gravity. And perpendicular to the surface, we have the normal force. Now, the tricky part about this question is that when we are writing our equilibrium equations in the x and y direction, the normal force and the friction force are kind of pointed in angled directions. They're not exactly in the x or the y direction. Now, one thing we can do to make this question a little bit easier is draw two x-axes and two y-axes. And this is because if we do this, every second angle will be the same. Now, let me show you what I mean. So if we draw imaginary lines from these forces, this is one x and y axis, and this is the other x and y axis. Now, we know that this angle right here is the angle of the ramp. That's the angle we're trying to find. So the angle between the friction force and this line right here is the same. Now, every second quadrant will have the same angle. So this has the same angle. This one doesn't right here, but this one does, and so does this one. So all of these angles are the same. Now we can write our equilibrium equations a lot easier. And by the way, I have a whole other video on this if you're kind of confused, but it just usually takes practice. So in the x direction, we want to sum up our forces to equal 0. Now the first force we have is the friction force, and that's acting in the positive x direction. So this will be F times the cosine of theta. Now in the negative x direction, we have the normal force, so we want to do minus the normal force times the sine of theta. Now, if this is also confusing to you, I have another video about forces in x and y directions, but again, it usually comes with practice. So remember that we want to find the static friction force, but we also want to find the normal force, and in order to do this, we'll need to write an equilibrium equation for the forces in the y direction as well. So if we sum up our forces in the y direction, we get, in the positive y direction, n times the cosine of theta minus the force of gravity. Now, since we want to find the normal force, we need to subtract the force of gravity from both sides and divide both sides by cosine theta. Now, I just substituted in mg for the force of gravity, just so you know what I did. So now, we want to solve for the friction force. And in order to do that, we'll have to subtract n sine theta from both sides and divide both sides by cos theta. So now what we can do is substitute the equation that we found for the normal force into this equation. And by doing that, we get F equals mg sine theta divided by cosine theta squared. Or another way to write this is cosine squared theta. So remember that the block will start slipping down when the force of friction is less than the coefficient times the normal force. So let me just write that out if that's a little bit confusing. So block will start sliding. So now we have an equation for the friction force. So now we just need to figure out a equation for this right here. Now, if you remember, the coefficient of static friction is 0.35 and the mass is 2.5 kilograms. I wrote that up here. So if we use the equation from above, we know that F is mg sine theta divided by cosine squared theta. And we know that the coefficient of static friction is 0.35, and we know that the normal force is mg divided by cos theta. So now all that we have to do in order to solve this question is to solve for theta. So this question is a little bit tricky, but if we multiply both sides by cos theta, then this cos theta on this side will cancel out and we'll be left with just one cos theta over here instead of cos squared theta. So now if we divide both sides by mg, both of the mg's will cancel out as well. So we're left with sine theta divided by cos theta is less than mu s. Now, if you remember, sine theta divided by cos theta is actually just equal to tan theta, is less than mu s. In order to find what theta is, all we need to do is the arctan of 0.35. So if we put this in on our calculator, then theta must be less than 19.2 degrees. So what this means is if our ramp is 19.2 degrees, then the box on top of it will not slide down. But if the ramp is greater than 19.2 degrees, like this, for example, then the box will slide down.